This is day 27 of Unit 7. We started today with this warm-up, so take a moment and try the warm-up. So number one, you want to pause the video first and try it, and then play to check your answers. Number one, I'm going to divide by 5 first, so e to the x plus 1 is equal to 16/5. Remember, it has to be an exponential form before you can solve by taking the log of both sides. So now that I have it in exponential form, I'm going to take the natural log of both sides, remember, because I'm taking the natural log rather than log base 10 because we have e in the problem. So when we take the natural log of both sides, first of all, I can use the power property and bring that x plus 1 out front. But secondly, the natural log of e, remember, is equal to 1. So really that just kind of drops out of our equation. So we have x plus 1 is equal to the natural log of 16/5. So now I can just subtract 1. Exact answer is natural log of 16/5 minus 1. Decimal approximation for that, 0.1632. Number 2, graphing. So hopefully you realize this is an exponential. So if I make just a quick table, putting 0 in gives me 10 to the 0 is 1. Putting negative 1 in gives me 10 to the negative 1, 1/10. Putting 1 in, 10 to the 1 is 10. So just plotting those couple points, 0, 1, 1, 10. Let's put it way up there. And negative 1, 1/10. Then I'm reminded, oh, this is going to be an increasing exponential with a horizontal asymptote at y equals 0. And 0, 1 is the locator point. Okay, so that's our graph for number 2, y equals 10 to the x. All right, today we had shortened periods, so we just got not a whole lot done, but we were working on page 26. So the first thing on page 26 you need to do is to graph y equals the log of x. Today we're going to be looking at log graphs. So in class I asked students, well, what's the base? And hopefully you remember that the base here is 10. So the first thing I'm going to do when trying to graph a log graph is to put that into exponential form. So in exponential form, 10 to the y equals x. And then I asked students, well, how do you think this graph, y equals log of x, or in exponential form, 10 to the y equals x, how does that relate to the graph from the warm-up? So let's look back a second. So that was 10 to the x equals y. Now we have 10 to the y equals x. And hopefully you realize that they're inverses. Okay, and couple ways to realize that. It's the exact same equation, but the x is where the y is, and the y is where the x is in the other equation. The other thing hopefully you remember is that when we first started talking about logarithms, we talked about the fact that logarithms are the inverse of exponentials, and exponentials are the inverse of logarithms. So if I have a log graph versus a log graph with a base of 10 versus a exponential with a base of 10, they're going to be inverses of each other. So what we can expect then is that this graph is going to be flipped across the line y equals x, reflected across y equals x, and we're going to get our log graph, which is the inverse. Now, normally though, when you're asked to graph a log graph, you're not going to have just previously graphed its inverse. So we're going to start from scratch. We're not going to use the prior table. But what we would do after putting the log in exponential form is we're going to, instead of inputting x values like we normally would do and get the y, we're going to input the y's to get the x. So I'm going to put a couple negatives, 0, and a couple positives in for y. Then I'm inputting them. So 10 to the negative 2 is 1/100th. 10 to the negative 1 is 1/10th. 10 to the 0 is 1. 10 to the 1 is 10. 10 squared is 100. Now, on page 26, you're going to have to make a large coordinate plane in the middle of your paper, taking up the whole page with the origin in about the middle. So once you have that, you're going to go ahead and plot these points. So 1/100th, negative 2, very close to the y-axis. 1/10 negative 1. 1 is 0, and then 10 is 1, and I can't plot 102. And if I kept plotting more values closer and closer to x equals 0, I would realize that there's a horizontal asymptote there. And I just have then this curve that's getting really close to that y-axis and goes like that. Okay, that is y equals log of x, or again 10 to the y equals x. And 1, 0 is the locator point. 0, 1 was our locator for the inverse for the exponential. 1, 0 is the locator point for the log graph. So that's our log graph, and it does have a vertical asymptote, which hopefully that's what you were visualizing a moment ago when you thought about taking this graph and flipping it across y equals x. I would get a vertical asymptote rather than a horizontal, and I would get that log graph by taking all those points and making the x's the y's and the y's the x. Okay, so there's our graph. So then the next thing we need to do is we need to graph y equals the log of x plus 5. Well, we already know what the log of x looks like. So we're going to take that graph and we're going to shift it based on all the shifts we've learned all year, and we'll get our new graph. So hopefully you remember that adding 5 on the end of something means an up 5 shift. So what I'm going to do is I'm just going to take, to get this table, I'm going to take the original table, and I'm just going to increase the y values by 5. Why? Because up is a change in y. So I'm going to copy the 1 100th, the 1/10th, the 1, the 10, and the 100, and I'm going to just increase the y values by 5. So, because we're going up. So 5 plus negative 2 is 3, 5 plus negative 4 is 4, 5 plus 0 is 5, 5 plus 1 is 6, and 5 plus 2 is 7. I'm going to plot those points, and then I'll have my log of x plus 5 graph equals y. Now, by the way, I did not put this into exponential form because of that plus 5. That plus 5 caused me to be unable to just go ahead and change to exponential form because it's not in log form. It has that extra 5. So I couldn't put it in exponential form. So that's why I had to think about what the log base 10 of x would look like in terms of a graph, and then I'm just going to shift that up 5. So I'm going to plot those points. 1 103. 1 103 is right about there. 1/10 is 4. Is right about there, and 1 is 5. 1 5 is the locator, by the way, because 1 0 was shifted up 5, and then 10 6 right there, and that's all I can really plot. So now I'm going to graph that. Now, notice the vertical asymptote x equals 0 did not change because all we did was shift up. So up or down shifts are not going to affect the vertical asymptote. So still x equals 0, and this is our g of x function. So I'll just label that. Okay, I'll label the 1 5, which is the locator point, and that's it. Okay, next one, b. H of x equals 5 times the log of x. Well, we just looked at a moment ago y equals the log of x. So that was equal to y, that was log of x. Now I have 5 times that. So hopefully you're realizing that that just means we're going to take the y value, because y is log of x, and we're going to multiply it by 5. Because I want 5 times the log of x, which is 5 times y. So that's exactly what we're going to do, meaning once again, I'm going to go back to my original table for 10 to the y equals x, or for log of x, and I'm going to change the y value. So I'm going to copy the x again. So each one of those y values from the log of x is going to be multiplied by 5. And hopefully you do know what that's going to do to the graph. You should. Putting a number, an a value in the front, and that a value being bigger than 1 is going to be a vertical stretch. So let's see what that is going to look like. So 1/100th, so -2 is being multiplied by 5, so that's -10. -1 is being multiplied by 5, so -5. 5 times 0 is 0. 5 times 1 is 5, and 5 times 2 is 10. I'm going to plot the ones I can. 1/100th is at -10. So down here, 1/10 is at -5, so right there. 1 is at 0, so right there. 10 is at 5, there, and I can't plot 100, so I'm going to make it go through those points. Whoops, it's going through that there. And the locator point is still 1, 0 on this one. So let me label that. That's my h of x graph. Okay, and that does look like what you expected. It was not shifted left, right, up, or down, but it was vertically stretched. This original graph, log of x, was vertically stretched to create that h of x graph. Okay, now there are two others on page 26, and that's what you're going to do for homework. You're going to do parts C and D. So you're going to figure those out the same way. You're going to figure out what the shifts were. You'll take this table, and then you'll change either the x values or the y values based on those shifts. And then once you do that, you'll get your new graph. Your new graphs, and you'll add those to the same coordinate plane. So that's what you're going to do for homework. Now, in most classes, we did start this one, and this one just goes in your notebook. So I'll go ahead and go over this, at least the first part of it, as well. So I think in most classes we were able to get to this. So we're going to graph y equals log base 4 of x. So still a log graph, so still going to have that same general shape, that curve with the vertical asymptote, but it's going to look just slightly different because this isn't base 10 anymore, it's base 4. So we're going to start this one the same way we did the last one, which is putting this log equation into exponential form. So if I do that, I'm getting 4 to the y equals x. Hopefully you see that. 4 to the y equals x. So now I'm going to make a table. And just like we graphed y equals log base 10 of x, we're going to graph y equals log base 4 of x the same way. We're going to input the y values and figure out the corresponding x. So -2, -1, 0, 1, and 2 are my inputs, which are my y's. So 4 to the -2 means 1 over 4 squared, which is 1/16. 4 to the -1 is 1 over 4, which is 1/4. 4 to the 0 is 1. 4 to the 1 is 4, and 4 squared is 16. So I'll plot those on my coordinate plane. You'll have to make yourself a coordinate plane in your notebook. So 1/16 is -2. 1/4 is -1. 1 is at 0. 4 is at 1. And 16/2 will be way over here somewhere. I'll just put it there. So I can see that, once again, I have that same general log shape, which you will, and, whoops, that's not supposed to go that far over. It's very, very close to the y-axis. So because it's very close, once again, I can see that the vertical asymptote is, again, x equals 0. My locator is, again, 1, 0. Okay. So really, it looks very similar, almost identical to log base 10 of x. Again, just some of the points are a little bit different because it's base 4, not base 10. And that's about where we left off in most classes. In some classes, we started example 2b, but for most classes, we didn't get to that. So we'll pick up there tomorrow with tomorrow's class. So for homework, I did change the assignment a little bit, and we didn't get to that, so I'll do that tomorrow. For homework, you're just going to do finishing up page 26 to the top of page 27. When you look at page 27, you'll see what I'm talking about, hopefully. There's a couple questions at the very top. Those are what you need to answer. I think I've already assigned the rest of page 27. So you're going to finish up page 26 and then the top of page 27. And that's going to be it. I'm not assigning this because we didn't quite get to enough of the lesson to be able to do that in class. So finish up page 26 and the top of 27 for tomorrow.